Hello, today we're going to be taking notes on long division. The question that we want to be able to answer by the time we're done with these notes is, how does estimation help us with long division? These notes are going to go on to page 28 of your interactive notebook. There's also a practice page which will be taped and added to page 27. Please pause the video if you need to write down your topic and essential question. This standard that we're going to be addressing today is 6 number systems, number 2. You should be able to fluently, which means with regularity or without any problems, divide multi-digit numbers. Multi-digit numbers are numbers that are greater than 2 digits. So greater than 19, 20, 35. We're looking at like 172, 1,028 bigger digit numbers, multi-digits. So I can fluently divide multi-digit numbers using the standard algorithm. There are other methods of dividing. We can use tables, base 10 models. There's a lot of different systems that we can use, but we're just using the traditional standard algorithm. Now when we do this, there is a 4-step approach that we go through, and we're going to cycle through this 4-step approach with as many digits as we have in our dividend. So the first thing that you need to know is it goes divide, multiply, subtract, bring it on down. And you're going to go through that same system over and over and over again until we have no more digits to divide. When we're dividing, we also need to understand that we have a division bar, and within the division bar we have the dividend, it's the number that's inside, and we have a divisor, which is the number on the outside. And when you look at a problem, we divide the dividend by the divisor. It's very important to remember. So this is the dividend, and this is the divisor. And the first step we're going to do is we're going to estimate how many times can the divisor go into the dividend. How many times can the divisor be divided, can the dividend be divided by the divisor? And you're going to go digit by digit. So we'll start with the digit that's closest to the divisor and work our way over and see if we can estimate in. So this is the step where we will estimate. So looking at our problem here, we would say, okay, can 3 go into 7? Class, can 3 go into 7?
Yes.
How many times, class?
2.
2 times, very good. So do you see how we made an educated guess? And that was a pretty easy one. Sometimes it's a little bit more complicated. But we're looking at how many times do we think, using our information that we know, it could go in. The second step that we're going to do is we're actually going to multiply. So if we had the problem 3 going into 70, or 70 divided by 3, we said 3 goes into 7 2 times. This is where we would actually multiply and figure out 3 goes into 7 2 times. So 3 times 2 equals 6. And you're going to write it here. So 3 times 2 equals 6. And you write it right below the digit that you were working with. Now the next step is to subtract. So we've gone from here to here. Now we're going this way. So now we're going to subtract. So we had 3 goes into 7 2 times, which was 6. Now we're going to subtract. 7 minus 6 is what, class?
1.
Good. So that's it. 7 minus 6 is 1. And the key to this, guys, is just make sure that you're lining up those digits. I didn't go 3 into 70, I did 3 into 7. So I want to stop there. It would be incorrect if I put this digit over here under the 0. That would make my problem wrong. So we want to make sure that we always make that problem lined up correctly. And one of the biggest things people get into trouble with when they do long division is not actually the division and the multiplication. They write their problems very sloppy, and they lose track of where their digits are. And because of that, they make simple errors just because they're sloppy. So we want to make sure that we're neat. Which brings us to our step here, which is to bring it on down. So we had 3 goes into 7 2 times. 2 times 3, which was 6. We subtracted and we got 1. Now we have this digit over here, this 0. We're going to drop that digit down, and we have 10 now. So now we brought the digit down and we can repeat the system. So bring down the next digit and repeat the cycle. So then we would say, okay, how many times do we think 3 can go into 10? Well, we think 3 can go into 10 3 times. Then we would say, okay, 3 times 3 is 9. We would put it down here. We would subtract, and we would keep following this system over and over and over again. And then we're going to get to the point where we will either, we'll move away from our traditional idea of remainders, and we'll start writing our remainders as fractions or decimals. And that'll be in the upcoming unit lessons that we're going to be doing. But for this particular lesson, just keep that idea of that cycle, that you just keep going until you can't divide any longer. So let's do a practice problem. Let's slide down our paper. And we're going to set up this practice problem, 39,060 divided by 12. Can anyone tell me what is the divisor in this problem? The divisor. Serena? 12. Very good. So 12 is outside of the division bar, right? Okay, which leads us, class, with what is our dividend?
39,060.
Good. 39,060. So the first step we do is we divide. With our division, we're going to estimate. How many times do we think 12? Now, first of all, can 12 go into 3? No, it's not big enough. It's too small. Can 12 go into 39?
Yes.
Yes. How many times do we think 12 can go into 39, Kiki?
I believe that 12 can go into 39 3 times.
Very nice way of stating your answer. Good job. That's a good guess. So 3. Now we're going to multiply. Class, what is 3 times 12?
36.
36. Very good. Now we're going to subtract. 9 minus 6 is 3. 3 minus 3 is 0. Now we're going to bring it down. And we're going to start the cycle again. 12 goes into 30. How many times do we think? Angel?
12 goes into 31 times.
Good. Oh, 12 goes into 31 time? 2. Way to fix it. Yeah. Because 12 would end up with too big of a remainder, right? You don't want your remainder having another 12 in it that you can pull out. So good job. So 12 times 2, and I like that you corrected yourself. Thank you for doing that, is 24. 2 times 12 is 24. We subtract. Class, what's 30 minus 24?
6.
And what's the next step, class?
Bring down.
Bring it down. Bring down the 6. How many times do we think 12 can go into 66, Riley? 5 times. Okay? 5 times 12 is 60. Subtract it. What's the next step, class? Bring it down. And once again, we have 12 goes into 60. How many times? Lane?
5.
5. 12 times 5 is 60. Subtract. And looky there, we end up with a perfect problem. So our answer here would be 3,255. If we divide 39,060 by 12, you get 3,255. 255. And I boxed my answers to clarify that this is my answer. Okay, so this one was pretty simple in the fact that we are used to dealing with 12s, right? That's kind of the biggest multiplication table that we remember. So now we're going to do one where it's a multiplication table we don't remember. So we're going to go to page 27 to one of our example problems. And on this one we have 65,232 divided by 18. Do any of you know what is the dividend in this problem? Maria? That's very good. I purposely tried to trick you. I switched it up on you. It is 65,232, which goes into the division bar, divided by 18. Now, before I start this, sometimes I like to give myself kind of a little toolbox of sorts to help myself out. So I'll say, okay, 18 times 2. Well, what's 18 times 2? 2 times 8 is 16, carry the 1. 2 times 1 is 2 plus 1 is 3. Okay, so now I do 18 times 3. 18 times 3 is, 8 times 3 is 24, carry the 2, and I end up with 3 times 1 is 3 plus 2 is 5. Alright, 18 times 4 is 4 times 8, which is what class? 32. Good. 4 times 1 is what class?
4.
Plus 3?
7.
So I've got 72. Now I'm going to do 18 times 5. 18 times 5 is 40. Carry the 4. 5 plus 4 is 9. And I'm going to stop there. So now I've got 4 different practice problems that can help me when I try to do my estimation. Alright. So I'm going to see, does 18 go into 6? Class?
No.
Does 18 go into 65?
Yes.
Who would like to give me a guess, an estimate on how many times? Hayden McCluskey?
3 times.
3 times. How did you know that?
Because 18 times 3 is 50.
Did I already do that problem and had it over here ready to go?
Yes.
So I'm good to go. Okay, so 18 times 3 is 54. So now I'm going to subtract. 5 minus 4 is 1. 6 minus 5 is 1. Bring it on down. Take my 2 and bring it on down. Now I've got 18 goes into 112. How many times? Noah Engel, what do you think?
6.
6. Why did you say 6?
Because 6 times 18 is 108.
Did you use this practice problem that we did here possibly to kind of justify your answer and make an estimate? Yes, you did. Very good job. Because we did this practice problem, I purposely went up to 5 because I knew I could then add multiples more and kind of figure out. It was a good stopping point for my estimation. Very good job. So 18 times 6 is 108. We're going to borrow here. 12 minus 8 is 4. Bring down the 3. How many times does 18 go into 43? Noah Mingba.
18 goes into 43 2 times.
Good. Once again, using our practice problems. That's 36. I'm going to borrow over here. And then bring it on down. And how many times does 18 go into 72? 18 goes into 72. How many times, Nathan?
18 goes into 72 4 times.
4 times. Did you use the practice problems we did?
Yeah.
Yay. Good. 4 times 18 is 72. We subtract and we end up with a 0. And that finishes our problem. So we know that 65,232 divided by 18 equals 3,624. Please do the final problem on your own before we meet the next time. Thank you very much and have a